Hello, dear students. Welcome to the Quantum Group. Let's see this question number 3.21 of Irodov. Question states, a ball of radius r is uniformly charged with a volume density rho. Find the flux of electric field strength vector across the ball section formed by the plane located at a distance r naught, which is less than the radius of the sphere and from the center of the ball. So suppose this is a solid sphere. The solid sphere has a volume charge density rho and radius r, and from its center at a distance r naught, a section is cut like this. This is a section, and this section is at a distance r naught from center. So within the sphere, first of all, if I write the electric field inside the electric field, I'll only write the magnitude of the electric field. So within the sphere, electric field has a magnitude rho by 3 epsilon naught r dash. Why I'm using r dash? Because I will use r dash as to a different point. This r dash is a distance of a point from center. This is valid for r dash less than equal to capital R. And obviously through all these points that of this flat light green surface, some electric field lines would cross. And to find the total flux, I will need to divide this region into a very small thickness ring. And one such ring is this. This is a ring. And suppose the radius of this ring is r, and this radius is r, and thickness is dr. This thickness, let me write with another color. This thickness is dr. This thickness is, say, dr. So what will be the area vector of this ring? The area would be, obviously, if you cut this ring, that length will be 2 pi r, thickness dr. So area is 2 pi r dr, and area vector will be the perpendicular to the plane. So at all these points, if I draw the area vector, this area vector would be like this. Like this. I think that r is not very visible, so make it with a black color. This is radius r, and thickness is very small, and distance of all these points from the center is, say, r dash. And at this point, this is the electric field. So this light blue color is the area vector. So this area vector is a dA vector like this, and at this point, electric field vector would be along this direction, radially away direction. So this is the electric field vector, dA vector. Angle at any point, dE vector, let me just write E. Angle at any point here, between dA and E vector is, say, this angle is, say, theta. So this angle will also be theta. So at all these points, magnitude of electric field is the same, that is E, and angle between E vector and dA vector at any point is theta. So flux through this little ring of radius r and thickness dr, this flux will be d phi is equal to E dot dA, and E dot dA will be simply E dA, and cosine of angle between them, that is theta. Now, how much is E? At a distance r dash from the center, as I've written here, that will be rho by 3 epsilon naught r dash, and dA is 2 pi r dr, and cos theta, you can see from here cos theta. How much is the cos theta? Cos theta would be, you can see cos theta is equal to r naught by r dash. So r naught by r dash, this r dash will get cancelled. So now I have flux in terms of the only one variable, that is r. So rho by 3 epsilon naught r naught and 2 pi r dr. So if I integrate this small r from where to where, this r will vary from here at this point small r 0. And if I keep on increasing the radius, the maximum radius of this flat region would be this. This would be the maximum radius, like this. And if I come up to here and join this line with here, and this is obviously, this is the radius of the sphere, and this radius, this is the r max, and this r max would be nothing but a square root of r square minus r naught square. So now I can find this total flux phi is equal to integration of d phi. Everything is fine, only variable is r, so that integration is going to be 2 pi r naught rho by 3 epsilon naught r2 dr. And let me call this r to be some, say this is r max, this is r max, and the small r will vary from 0 to r max. So I'll come back here, this phi will come out to be 2 pi r naught rho by 3 epsilon naught. This integration will be r square by 2, and if I put the limit, I will get r max square by 2. This 2 gets cancelled. So pi r naught by 3 epsilon naught rho, and value of r max square will be square root of r square minus r naught square. And if I take the square, I will get simply this thing. So this thing I've got as a final answer, as a flux crossing through the ball section formed by the plane located at a distance r naught from the center. And this is my answer. Thank you.